What if you could visit the past? It's a question that fuels our biggest stories, our wildest daydreams. But today, we're going to dive into a pretty compelling argument from physics that says this dream isn't just difficult, it's fundamentally impossible.
Right? I mean, who hasn't? The idea of seeing history with your own eyes, meeting your great great grandparents, or maybe just reliving one perfect day, it's just so powerful. It's a fantasy that's completely woven into the fabric of our culture. And let's be honest, science fiction is the main architect of this whole dream. Countless stories have made hopping into a time machine feel as casual as starting a car, making the impossible feel like it's just around the corner. But here's the thing. What happens when we swap those sci-fi novels for actual physics textbooks? Well, that's when the fantasy collides with a very, very different reality. The rules of the actual universe, it turns out, paint a much starker picture. So we're going to look at a perspective that doesn't just question time travel, it dismisses it completely. And it's a pretty blunt one.
Yep, there it is. No wiggle room, no what ifs. According to our source, the entire concept is simply nonsense. It's a pretty jarring statement, especially after a lifetime of dreaming about it. You know?
So why is such a hard no? Where does all this certainty come from? Well, it turns out the answer lies in a clash between two different ways of looking at the fundamental laws of physics.
A lot of the confusion seems to come from these two different ways of seeing the universe. One view kind of leaves the door cracked open for speculation, while the other one, well, it slams that door shut and throws away the key. And this is really the core of the issue. On one hand, you've got what our source calls conventional physics, which kind of, sorta allows for this kind of speculation. But then, on the other hand, you have more complete, more elaborate theories that make it immediately crystal clear that it's impossible.
So what's the deal with conventional physics? Think of it like a map that only shows the major highways. It's useful for getting around, sure, but it's missing all the local roads, the side streets, the little details. Our source says it lacks the complete machinery to give us a full picture of reality. It's like moving from a simple blueprint to the full detailed schematics. To get the real answer about time travel, we have to engage with these more complete theories. And it's inside that more detailed machinery that we find the specific reason why traveling to the past it just can't work. And in those more complete theories, we find the exact reason why traveling to the past is a non-starter. It's a concept called the interference effect. Okay, let's break this down because it sounds complicated, but it's not. Imagine you try to create a small bubble of space where time runs backward. The moment you do, the rest of the universe, literally everything around that bubble, immediately interferes and stops it from happening. The universe itself fundamentally prevents these kinds of local reversals. So it's this simple three-step chain of failure, every single time. 1. You attempt to reverse time. 2. The surrounding universe immediately reacts to stop you. 3. The attempt fails. This isn't a technological problem we can solve someday. It's a fundamental rule of the cosmos. Now, this conclusion, that time travel is impossible, isn't just a fun scientific fact. Our source argues it comes with a real-world responsibility, which leads to this really powerful ethical plea. This is a pretty strong statement, right? The argument is that because time travel is impossible, it's totally irresponsible to suggest that it is, especially if you're doing it to make money or get famous by selling people a false hope. And this is the final plea. It's really a call for intellectual honesty, a responsibility to not mislead people who might not have a background in physics. It's a serious warning against blurring the line between great science fiction and actual science. So the key takeaway here is this. Our awesome dream of visiting the past crashes right into the hard wall of physics. The universe, it seems, has its own error correction system. It's called the interference effect, and it makes sure that the timeline always moves forward. So if we can't change the past, where do we direct all our curiosity and passion? Maybe the real frontier isn't behind us, but in all the incredible, actually possible discoveries that are still waiting for us up ahead. What do you think is the next great frontier we should be exploring? That's all for this explainer. Thanks for tuning in.